resume in the class, students. Due to technical reasons, the class is adjourned for 5 minutes. Let us start. The advantages of SMA are very high power weight ratio comparatively. Accessible voltage can accomplish thermoplastic transformation, higher strain recovery, higher strength, compactness allowing for reduction in overall actuator size, noiseless and silent operation, high corrosion resistance. So these are the advantages of using shape memory alloys when compared to the remaining alloys. That's what we can understand here. So very high power and weight ratio is possible. Accessible voltage can accomplish thermoelastic transformation, higher strain recovery, higher strength, compactness allowing for a reduction in overall activator size, noiseless and silent operation, and high corrosion resistance. So these are the properties. I think everyone know the high power to weight ratio. That means the basically component is going to less weight, but it is going to produce high power. Thermoelastic transformation is possible. Higher strain recovery is there. Higher strength is there, and compactness allowing for reduction in overall activator size, noiseless and silent operation. Corrosion resistance is everyone know. Okay, this is a important advantages. Next, limitations of SMA. So heat dissipation need mechanism for cooling. That means for dissipation of heat. Why? Because we are already saying that when transformation temperature is reached, we cannot able to regain its original shape and size. That's why we should go for this type of mechanism. Next, less stiffness to high flexibility. Less stiffness. I think what is the stiffness? Ability of the property which resists the deformation when load is applied is going to be called as a less stiffness. Flexibility means, I think everyone know, having a high nature to mold to any shape and size based upon that one. So there is high flexibility for shape memory alloys. So it is a disadvantage. Why? Because it has to come to its original shape and size. Relatively expensive to manufacture and machine compared to other materials such as steel and aluminum. So relatively expensive to manufacture and machine compared to other materials such as steel and aluminum. Compared to steel and aluminum, shape memory alloys are going to have a higher cost. Next, most SMAs have poor fatigue properties. Pure fatigue properties, what is the fatigue property? A property that is going to have high stresses and low stresses in a short time is going to be called as a fatigue property. If fatigue property is poor means within less time it is going to be fail its function. So that is the thing to remember here. So most SMAs have poor fatigue property. That is, a steel component may survive for more than 100 times more cycles than SMA element. So for example, they are saying that a steel component can survive its function 100 times more cycles than SMA. SMA metal is less than the steel component. For example, steel component is functioning 100 cycles. So SMA point function only one. Basically, any steel component can have a fatigue composition around 10,000 cycles, 20,000 cycles based upon the application. So I repeat once again, what is a fatigue means? Maximum load and minimum load in a short interval of time on a metal is going to be called as a fatigue load. So most SMAs have poor fatigue properties. That is, a steel component may survive for more than 100 more cycles than an SMA element. Next, relatively expensive to manufacture and machine compared to other. So limitations, if you observe, heat dissipation should be done for a shape memory alloy. Less stiffness is there, relatively expensive. And next one is when terms of cycling operations, it has a poor functions. So this is the another limitation of SMA. Next. Applications of SMA. If you observe, based upon the observations, one is about aircraft, second is about the automobile dome. If you observe that one, arrowhead, we are going to observe that red color. Here also, if you observe wings, at the wings we have a propeller will be there. At the propeller we have a SMA internally fixed. That's what we can understand. So shape memory alloys have very vital role in the aeroplanes, or we can say about aeronautical applications. So if you observe this red color, this is a 201 for Chevrolet. Chevrolet uses a lightweight heat activated shape memory alloy, while in place of heavier motorized part to open a vent that allows the trunk lid to closely more easily. So instead of having a heavy part here, they have gone for a shape memory alloy. Today, Chevrolet company has gone for a shape memory alloy to replacing a lightweight part so that they can able to reduce the weight. The functioning is one and the same. So thereby the import functioning of the component has increased. This is only two examples I am referring here. In terms of application, that means in aircraft, in automotive we can use. In aircraft, wings are there. What is the main function of this wing is to reduce engine noise. Some designers installs chevrons onto engines to mix the flow of exhaust gases and reduce engine noise. To reduce engine noise also, we can go for this type of SMA alloys. Next, in robotics applications, recently a phorophotic hand was introduced by Loho, all that can almost replicate the motions of a human hand. That means a shape memory alloy has designed by a all others, that is it all, that means all including that LOH, design a shape memory alloy for a hand so that it will behave like a human hand only. That's what they are referring here. In civil structures, SMS find a variety of application in civil structures such as bridges and buildings. One such application is intelligent reinforced concrete IRC, which incorporates SMA wires embedded within the concrete. Instead of having a steel rods, so having a steel cables, they have gone for shape memory alloy along with the concrete. Another application is active thing of structural natural frequency using SMA wires to dampen vibrations. For dampen vibrations also, we can go for the shape memory alloy. So broadly, how many are there? First, we have aeronautical application is there, automotive application is there, in robotics application is there, in civil structure is there. If you observe this diagram, concrete column is there, SMA rod is there, steel rod is there, SMA bar and charge for a column. Next, piping. The first consumer commercial application was a shape memory coupling for a pipe. Examples are oil line pipes for industrial applications and water pipes. Use of memory alloys for couple tubing. Memory alloy coupling is expanded. A. It fits over the tubing. B. When the coupling is reheated, it shrinks back to its original diameter. C. Squeezing tubing for a tight fit. So, a shape memory alloy has already three types of behavior. It can compress, it can expand, it can once again fit to its original shape. That means by heating is possible, by cooling is possible, by original temperature also it can regain its shape. That's what use of shape memory alloys for coupling tubes. A memory alloy coupling is expanded as it fits over the tubing. B. When the coupling is heated, it shrinks back to its original diameter, squeezing the tube for a high fit. Next, in medicine applications. In medicine, stent, a reinforced grafts for vascular application to replace or repair a damaged arteries. A diameter is 25 mm. So this If you observe this one, in medicine applications also, shape memory alloy can be used in repairing the or in replacing the vascular applications, particularly these arteries. Arteries and veins are going to activate the blood in two ways. If you observe, one is sending and one is from all parts to the heart. If you observe, this blockage is there. Here one example they have referred. This blockage is replaced with a stunt placed. The stunt is going to be our shape memory alloy, which having ability to expand and compress. Here it is closed. So by using this one, it can able to allow the blood to pass through that artery. So that's a decreased flow blood if you observe this one due to this bulging. By using this shape memory alloy, we will bring it to normalize. So next, optometry. So optometry is another application, that is optics means glass. So eyeglass frames must be from titanium containing SMAs are marketed under the trademarks of Flexon and Titan Flex. So it is SMAs have a trademark, that is Flexon and Titan Flex are prepared with the shape memory alloys. The frames are usually made of shape memory alloys that have their transition temperature set below the expected room temperature. This allows the frames to undergo large deformation under stresses, yet regain their intended shape once the metal is unloaded again. So this is a thing. So shape memory alloys are used in opticals also. While designing that one, the temperature should be less than the room temperature. And second point is for large deformations under stresses, regain the intended shape once the metal is unloaded again. This is the future scope. There are many possible applications for SMAs. Future applications are envisaged to include engines in cars and aeroplanes and electrical generators, utilizing machine energy resulting the shape transformations. Nitinol with its shape memory property is also envisioned for use of car frames. Other possible automotive applications using SMAs springs include engine oil, carburetor, and engine lubrication controls, and other control of a radiator blind to reduce flow of air through the radiator and start up when the engine is cool, and hence to reduce the fuel usage and exhaust emissions. So altogether, if you observe the applications, there are number of applications are there. As already told that we have aeroplane is there, that is aeronautical application is there, automotive is there. Third point is in piping industry it is possible, civil structure is possible, robotics it is possible, in medicine also it is possible, and next one is about optics also we are going to useful this one. So total we have 8 applications for this shape memory alloys. So if you observe these conclusions of the shape memory alloys has a bright future in the coming days. Second one is it currently used in number of departments in robotics, in defense services, in aeronauticals, like so on. Innovative ideas for SMEs for number of products on the market using SMEs continuously growing. Advances in the field of shape memory alloys for use in many different fields of study seem very promising. That means shape memory alloy has a promising sector to do a research work, to expand the business, to expand the manufacturing of products, because it has a very vital role in number of applications. So these are the conclusions. The material is collected from the following references. You can have a glance on that one. Wikipedia, first one is textbooks are there. Stanford.edu is there. Wikipedia is there. As is a new topic, it has collected from number of sources. Thank you, students. Okay, before going to conclude, the I want to explain what are the key points I have covered in this class. First, I have covered about super elasticity behavior of a shape memory alloy. Second, I have covered about applications of a shape memory alloy. Third one is conclusions of a shape memory alloy. The notes is given in the classroom code and department link also it is possible. I'm going to show that one. So this is the classroom code. Google Classroom code you open, download and open, and it asks for the code. You will simply type GMTKRTQ. All are small letters. Thereby up to 5th unit I have provided the given the notes in Google Classroom code as well as department link. All of you use that one. So before closing this one, let us have the brief talk of the unit 5. One is about functionally graded materials. Second one about the functional shape memory alloys. For these two, you have to learn about properties, applications, classification, and characteristics. Limitation, these 5. In shape grade, in functionally graded materials, that is FGM, we have to know about the methods to prepare FGM also. Already I have given a slide presentation. You can have the complete notes in this Google Classroom code. See you students. See you all. Have a good day. Bye.